Hello, hello, and welcome to week 11, day 1. Here we go. Hopefully you're watching your videos, you're doing your homework, and you're keeping it all together because we are on the downhill slide to the final exam, which is just a few short weeks away during week 16. So, yay! This is the last of the new material for your exam 3. So we're going to wrap up Algeblocks this week. And right now we're going to talk about using the Algeblocks to tie in with the factoring processes that we go on in the classroom. So basically, I know that everybody that I'm talking to right now knows how to factor, but what I'll say is there's a lot of different processes for that, and what we're going to do is we're going to try to tie the Algeblocks in with what we would want to do. So some stuff that we might be doing: trial and error. Okay. The trial and error method is really good if you are really good at math. So for instance, if I'm just going to factor a trinomial, I'll probably do it in my head because I can kind of look at it and say, okay, what times what gives me that, adds to that, blah, blah, blah. It's a lot of mental math, and there's a lot of trial and error. So there's some guess and check and stuff like that going on, right? Okay. The box method. The box method is really good if you need an organizing tool. So sometimes you'll have a student. I remember when I was teaching in a dual credit high school class that I had a student who had Tourette's, and he was just all over the place on his paper. You know, he might write something up here, and he might write something there, and then something over there, and then something over there. It was very hard to keep him organized. So anytime I had some kind of a graphic organizer or something like that that would help him keep things in order, I would try to use that with him. To me, though, the box method, it's a good method, and lots of people use it, but what I think about the box method is I think it's like AC method with extra steps. Okay, it requires the students to place things in a certain order or know that there are different boxes that they need to fill in, and it's really good, like I said, for an organizational technique. I just don't know that it's good for every student that's out there to be able to have to do the box method, honestly. To me, it's cumbersome and it makes them do extra work. So I don't use the box method. I'm not saying there's anything wrong with it. In fact, I'm sure you can go on YouTube or go to Khan Academy or something. Look up box method trinomial factoring, and I'm sure they'll show you stuff. But I'm not going to spend any time on that. I just want to make sure we all have one method that we can see, and then we're going to tie the Algeblocks to the method. So the method I'm going to use is the AC method. And the reason that I use it, actually the department here in Commerce has kind of adopted the AC method. If we're trying to show some of our college algebra or intermediate algebra students how to factor, we use the AC method in general. Okay, so here's the reason. If a trinomial will factor, the AC method will work. So that's the nice thing about the AC method. Every single time the students know there's a particular process, there's particular steps that I walk through, and if I do it in a particular way, if this thing factors, I will find the answer. So that's why we like to do that with our students, especially, like I said, in the lower first year math courses. So I started this video and I had to come back and redo it. So that's why I already have some stuff written. Sorry, guys. Okay, so the quadratic equation in the standard form, you should have seen it before. It should come out ax squared plus bx plus c. Okay, that's called standard form. And if you were in a college algebra class, here's my example. 2x squared plus 5x plus 2. If I was in a college algebra class, I would probably set this thing equal to 0, and it might say solve. But in this case, I'm just going to say factor completely. So the directions for this thing are factor completely. So I need to look and say, is there a GCF in there? No, I don't see a GCF. Okay, then instead of worrying about a GCF, because I don't have one, I'm going to go straight to the AC method. So here's where we are. The first step of the AC method says multiply A times C. So I need to set that up so that I can see which ones are which. So if I look right here, let me scoot it up a little bit. Is this in descending exponent order? Yes, it is. That's just like in standard form. And if that is true, then the number that's in front of the x squared, that coefficient, will be my x. a, right? So a equals 2. I've got it written down on the side here so we can see it. Okay. The number in front of my x, that's going to be my b. So b is 5. So I've got that written down here. And then the number that doesn't have any x's attached to it, it's just a constant number sitting out in the back. That's my c. So c equals 2. Okay. So first step is multiply a times c. A times c for me is 2 times 2. So that's 4, right? Okay. And then the second step is list out the factors of the product AC. So here I a lot of times will put it into a T-chart kind of look. So over here I've got my factors. So how many ways, what are all the factors of 4? So I can list them. It can be 1 times 4, right? Okay, it can be 2 times 2. That's the way we got it to begin with, 2 times 2. And I'm going to keep in the back of my mind, if I saw some negatives, like if this was a negative here in the middle, then this was a positive in the back, then I would know that it was a negative times a negative gave me a positive. So I might have, for instance, -1 times or -4, or -2, sorry, times -2. I might have those. I don't need those in this situation because these are both positives. But just remember, these numbers, how they multiply out to give me whatever my AC was, those will change if, for instance, AC was a -4. If this was a negative back here, then I'd have something different. Or if the number in the middle was a negative, then I'd know that, hey, they need to add up to a negative number. Okay, so I don't need these two down here right now. Just keep them in mind as you work through other AC method problems if you're going to do that. Okay, so step number 3 is add the factors and look for the pair that adds to equal b. B is the middle coefficient, right? Okay, so I'm going to add them up, and I'm looking for the pair that's going to give me, in this case, I'm looking for a 5, right? These are my generic statements over here. I know. Sound effects don't even cost you extra in this situation. That's awesome, right? So these are my generic steps. Oh, sorry. Everything on that side of the pink line is specific to this example, right? Okay, so adding them together, I would do 1 plus 4, that's a 5. And down here I would do 2 plus 2, that's a 4. Okay, there should only be one of those sets that actually gives me my B. So I want the one that adds up to B, which is the top line, right? That's a 5. Okay, so I know that I want 1 plus 4. So the next step is replace the BX term with 2 terms made up of the factors from step 3. Made up of the factors from step number 3 above. Okay, so here, so what we're saying is we're going to take our middle term, our BX term, and we're going to split it into 2 terms. We're going to replace it with 2 terms in there, and whatever it is, those 2 terms are still going to equal BX, because I don't want to change the value of my factors. You know, I don't want to change the value of this quadratic formula or quadratic expression, but I do want to take it and make it a 4-term polynomial instead of a trinomial, right? So that's kind of the trick here. This makes a 4-term polynomial. You got to be able to do that because in a minute we're going to factor by grouping. So let's use that here. Sorry, I'm running out of time, out of room here. So I've got the first term is just what it already is, the ax squared, so I've got 2x squared. I've got a plus, and I need 5x, but I'm going to use these factors to make it look like 2 terms. And I'm going to hold on to the x because he's always going to run along with me, right? These are just going to be the coefficients. So how can I make these add together to give me this? 5x. So I see a 1 and a 4, but I don't want to just write the 1, right? I want to tack the x on. So 1x plus 4x. So what we're saying is whatever I have here, I'm just splitting the middle term here and making it into two separate terms. So the plus 2 will just hang around at the end, right? So is that an equivalency? That's what we want to know. We didn't really change the value, we just changed the way it looks, right? So here I've got 1x plus 4x, that's equivalent to 5x here, okay? And what I've done, again, I started with 3 terms here, now I'm doing 4 terms here. So now step 5 is factor by grouping. Okay, so hopefully everybody knows how to factor by grouping. If you don't, go brush up on it a little bit so you can see how these tie together. The first 2, I'm going to group those guys together. I've boxed them up. And what I'm doing is I'm looking to see, do they have anything in common? 2x squared plus a 1x. All I see is an x, right? That's okay. Whatever they have in common, I'm going to pull out of that group. That's why they call it factor by grouping. Okay, so they have an x in common, and whenever I'm finished, I'll factor an x out of here. That's 2x. And when I'm finished here, that's a 1, right? 2x plus 1. If you're not sure, you could always come in and act like it's a division problem, right? Because factoring and division are very closely related. And you can say, what happens here when I divide that out by x? I divided the x out in front, so to speak. Well, that would go away, and the square would go away, right? So I'd have just that 2x left right there, okay? And if I divided this by x, those would go away, and I would just have just that plus 1 there, okay? So if you need to go in and kind of mark it out, divide it out, whatever works well for you, okay? That's my first group, okay? I'm going to group these together, these last 2 together. I'm going to be a little bit careful. I can be lax whenever it's a plus sign out there, but if it were a negative sign out there, I would want to factor a negative out of both of these so that I could have a negative there. I don't have a negative, so I'm not going to stress too much. But I want you to realize whenever I group, if that was a negative, I'm really grouping it all together, right? Whatever that sign is. So if it's a negative out in front, you're automatically basically factoring a negative out, okay? And then I look at these and I say, what do the 4x and the 2 have in common? They have a what? A 2. And whenever I divide 2 out of this first term, 4x divided by 2 is 2x. And when I divide 2 out of the second term, I get 2 divided by 2 is a positive 1. Okay? And here's the big kicker. The big, thing that I need to look for is that if I've done it correctly, the things that are in parentheses should match. I used to have a friend that called that twins. They should be exactly the same. If you're off by a negative sign or something's weird, this is a 1 and that's a 3, then you didn't do it right or it won't factor. Okay? It is a possibility that whatever trinomial you're working with just doesn't factor. Okay? So here I go. I've got that. I factored by grouping, and then last step, I want to factor out the common 6. Factor out the common GCF. Greatest common factor, right? That's what that means. Greatest common factor. In this term, what they have in common is the 2x plus 1, right? That's exactly, I wanted them to have that in common. So to do that, let me draw my pink line a little bit farther. I'm going to say, oh, they have a 2x plus 1 in common. I'm going to pull that guy out. Okay, write him in front. And then whatever's left makes me another set of factors. So I've got x plus 2. That's what's left over after I pull that GCF out. Okay, the GCF being the 2x plus 1. Alright, so I've done my factor by grouping, I pulled out my GCF, and voila, there I have it. That guy is factored. Okay, so that's the whole process of what it looks like to do the AC method. Okay. The biggest thing I would say, the biggest trick, so to speak, is to take that 5x in the middle, the bx term, and make it look like two separate terms. So you're splitting it up. So you got to be able to do that. And what I'd like to do is I'd like to say, okay, so let's think about that, and let's work this guy out using our Algeblocks. Okay, so that's where we're headed with it. Can we kind of tie that together and see, oh, this is what factoring a trinomial looks like. So I'm going to leave that just a little bit. I'm pulling up my Algeblocks quadrant map, right? And I've got my factor track. So hope everybody's done with that. I'm going to cover it up so we can see this. Back up a little bit so we can see the whole quadrant map. Alright, and oh, the stinker doesn't want to sit right underneath that document camera with the factor track. So there we go. Back it out a little bit more. Sorry about that. It always does weird stuff. Okay, so my equation was, or my expression was 2x squared. So I'm going to stick those out there. Hopefully you've got your algebra tiles or your Algeblocks ready to go. Okay, 2x squared plus 5x's. And they're all positive, so I'm just sticking them here in quadrant 1, and we'll see what happens. Okay, and then plus a 2. All right, and we did just the basics of factoring the other day, so we know that what we're trying to do here, let me scoot it down because they're all in quadrant 1. Did I say 2? I meant 1. I hope I said 1. Oh, it was plus 2. Yay, okay. So I want to make a rectangle out of this, right? And I'll just say there's kind of a method to the madness as you get used to it. I like to start with my two biggest, like I've got the two x squareds. I like to start with the biggest blocks first and then kind of build around them, see if I can make things fit. So for instance, I see that there's an odd number of blocks here. So and I see there's 2 across, 1 down. So I'm thinking I'm going to put the odd man out right here. Okay, and then I've got an even number of blocks. I'm just going to shove them up here on the top. Okay, making sure, like we talked last week, that everything breaks in the same points. Do not mess that up, especially on exam 3 when you've got plenty of time to talk it out to yourself and set up the problem in advance and work it out. So again, right here, we're breaking in exactly the same spots off of those units, right? I just filled in the gap. Okay. So without any kind of warning whatsoever, I've got a nice pretty rectangle. Nobody said, well, what I mean by warning is nobody said divide this by x plus 2, right? I just line them up and I see what's going on. And now I'm going to find the factors. So on the bottom, that's 2x, right? And a 1. Dropped 1, no. Okay, and going up and down, that's x plus 2, right? Okay, so I see exactly what's going on there. I can see that I've got the right answer, so to speak, right? Let me pull that back down. We had 2x plus 1 and x plus 2. 2x plus 1, x plus 2. So I have the right answer. There's my factor track, right? And so I can come up with the same answer like with that. But what I want to do is just for a second, I want to tie in the two processes. So let me come back here and talk about that splitting process in particular is what I'm worried about there. Trying to get rid of some of the glare, sorry. Okay, that splitting process right here, where I split the 5x and I made it 1x plus 4x. That's the same thing I did when I said, hey, look, it's an odd number. I'm going to put 4 there and 1 there. Isn't that the 1x plus the 4x? Yeah, it is, right? Okay, and then I just stuck the 2 in because they fit. Interesting thing is, if you go back a little bit in your algebra knowledge, there's something that's called, and it's not a fun process necessarily, but we all learn it, completing the square. Completing the square. Okay. And in actuality, it should probably be called completing the rectangle, okay? Because in this case, I was completing a rectangle, right? So I want to see how things fit in there. And whenever I look at it, I say, oh, okay, I had that. I need to split it up in such a way that it'll make a rectangle. So it's the same thing, same kind of thing that you've done in the past, hopefully. So you'll see that will actually tie in quite nicely if you go through, and it would be actually completing the square. If I had a perfect square trinomial, you would see an exact square then. Right now we're just working off of a rectangle, okay? So it's not quite the same process, but it's the same concept. If you're in a history class or a geometry class, you might see something like that come in where we say, hey, where does that square thing come from? Or where does that, like, why do we call this x squared? I think I mentioned this last week because it's literally a square, right? So completing the square, completing the rectangle. Square is just a special kind of rectangle, right? Okay, so that's kind of the process that's going on there. So that would tie in a little bit with stuff you might have done there. But the big thing for me is, like I said a second ago, the splitting of the factor from a 5x to a 1x plus 4x. Seeing that that can be substituted out and made into two different terms. That's a big deal. Okay? All right. So what I'd like to do is, this video will probably be relatively short. I'm almost done actually. I'd just like to work one other problem, and if you have questions or you're just not seeing it, like I said, go find some other YouTubes or come see me in my office if you can. Call me, send me an email, do what you can do, and we will see if I can do something else to help you with the process, right? So hopefully we see stuff going on and it'll be okay. Okay? Alright, so next up, I would like to work this problem, and what I want you to do is I want you guys to actually work the problem out, and first of all, sorry, I'm writing at the same time. I want you to first of all work it using the AC method. So I want you to get a little bit of practice doing that. So again, we want factor completely, and your problem is going to be 3x squared minus 10x minus 8. Okay. So first, just the process of learning how to factor using AC method. Make sure you can do it and you can move on with that. Okay, so what would you have me do first if we're doing this AC method? Hopefully you're saying multiply the E times the C, Dr. Webster. So over here on the side, I don't know, I'm being silly tonight. A, B, and C. The A would be a 3, the B would be a negative 10, and the C would be a negative 8. Does everybody agree with that? A, B, and C. Okay, so if I agree with that, then A times C is going to be 3 times negative 8. And I started throwing in a bunch of parentheses here, right, because I see a negative sign in there. So I want to make sure I do it right and everything's represented properly. So as I do that, I say that's a negative 24. Okay. And so now I'm going to come off to the side and I'm going to say, okay, what is, and I'm going to shorthand it here, A times C, all the different ways, okay, factors of A times C, and then add the factors. Okay, that's what I'm looking for. So what all could multiply together to give me a negative 24 is what I want to know. Okay, so I'm going to just play a little bit devil's advocate or whatever. I could have a 1 times a 24. Okay, and the reason I'm doing this, I want to throw a little extra something in here. I see, we all know there's a negative going on here, but I see in the middle, I'm trying to add up to the negative 10x, right? And I know my integer rules. Whenever I'm adding to a negative, that means I subtracted two things and I took the sign of the bigger number, right? So I know that the bigger number is going to be negative, okay? So I'm going to put the negative right here, and then when I add those, it will be 1 plus negative 24. Well, that's negative 23. That's not what I want, right? So that's not it, okay? No worries. Let me zoom just a tiny bit. Sorry about that. It went away whenever it zoomed out when I was doing the quadrant map. Okay, so 1 times negative 24. And I know I don't need to do negative 1 times 24 because that would give me a positive 23, and that's not going to be what I'm after. So if I switch these signs, put the negative on the smaller number, I'm just getting the same thing here but with the opposite sign, right? So I don't want those. So I'm just going to go through and I'm going to do 2 times negative 12, okay, because that would be the bigger number. So the bigger number gets the negative here. And then I'm going to do 2 plus negative 12. Now I happen to get it on the second time, right? That gives me a negative 10 when I add those. 2 plus negative 12 is negative 10. Okay, so I got it right there. That kind of looks like a 70. Sorry, negative 10. Okay, maybe that's better. Okay, but that's the combination I want. Just to be clear, though, I could keep going. I could do 3 times negative 8. Well, 3 times negative 8 gives me negative 24, and 3 plus negative 8 would give me a negative 5. And I know that I've gone on the other side. I was too big of a negative, right? Now I'm too small of a negative, so that's not going to be it. And the other option would be 4 times negative 6, and 4 plus negative 6, again, going the wrong direction. I'm getting a negative 2. So for sure, we got the right combination there on the second try, right? That's the one I wanted. Okay, so I've got my A times my C, and I figured out what the factors are. I figured out which one will add to the middle term, and now what? Now I need to come back here, and I need to replace the middle term with 2 terms, right? So let me see what that looks like. I've got the 3x squared. I've got a positive 2, and I'm going to add the x. Let me do these in a different color here. Plus 2x, right? And then I've got a negative 12, and I'm going to add the x on that. They've got to tag along. And when I look right there, what I just did was I replaced negative 10x with these 2 terms. Right? So when I do that, I better be able to say, hey, that works. Okay. Plus 2x, negative 12x, that's going to give me a negative 10. And then I still have the minus 8 hanging around. Okay? So go ahead and see if you can't do factor by grouping. Remember what I told you. When you group these suckers, this negative sticks with that group, right? You don't leave it out in front, because otherwise that'll give you a negative, the wrong negative sign inside of the parentheses, right? So I'm looking at 3x squared plus 2x. What about that? I hope you said they have an x in common. If I factor the x out of there, that leaves me a 3x. And if I factor the x out of this term, it leaves me with a 2. So in the parentheses, I've got 3x plus 2. And hopefully, if I do this right, I'll end up with a 3x plus 2 in the second set of parentheses, right? Okay, so what did I say about if you've got a leading coefficient with a negative out here in the one of the sets? I'm going to factor out the negative, right? This one works out nicely because there's a negative in both of them. If it had have been, though, negative 12x plus 8, I would still factor out the negative, but this plus 8, whenever I divide out a negative divided by, or I'm sorry, it would be a positive. Positive divided by a negative, that if it was a positive sitting there, it would change to a negative, right? Okay, what else do they have in common? Hope you're saying a 4. They have a 4 in common. So that leaves me a 3x whenever I divide the 4 out of the 12x. And whenever I divide the negative out of here, negative 8 divided by negative 4, I get a positive, and dividing by the 2, I get a 2, and I'm feeling very fortunate right now because these guys match, right? 3x plus 2, 3x plus 2. And so I see that twin thing coming in there, and I'm going to factor this greatest common factor out. So that goes in front, 3x plus 2. They go away because I factored them out in front. And then what's left over is its own factor, so x minus 4. Okay, and as always, everybody knows, I hope, that you can multiply these two back together, distribute, FOIL, whatever terminology you like. You can multiply those two back together, and you better come back out with what I started with, 3x squared minus 10x minus 8, right? Okay, so real quickly, we're going to tie the algebra blocks to that and see what happens. I need 3x squared. I'm going to have to be a little bit careful because the 3x squared is positive, but the other two are negative. So just need to be careful where I place things. I've got a negative 10x, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Lay them all out there so you got them. And I've got a negative 8, right? 1, 2, 3, 4, 5, 6, 7, 8. All right, so there. I've got it represented on the mat. I'm going to cover this up so I can see what's going on with the thing. All right, and now I'm looking at it and I'm saying, okay, what the heck am I going to do with this guy? Because the 3x squareds are the only thing that are positive. We talked a little bit last week about lining things up and how to know which way things are going to go. So there's really only two ways that the 3x squareds can go, right? They can go here or they could go up vertically. So if you wanted to go up vertically, you could. You just change the direction of your x's. I'm going to do them like this because I like them to lay down there. Okay, and then I think, okay, well, I've got negative 12 here. Oh, sorry, it was 10, not 12. Negative 10. Okay. So I could line them up just like that. But then these guys need to be negatives also, right? So I'm like, okay, dang it, this is a problem. So I think to myself, well, maybe I need to do some stuff in other quadrants to line stuff up in a particular way. In my book, I'm thinking these guys are negative. They need to line up at the bottom. Well, where do you think? They need to line up at the bottom. If they're negative 8s, they need to line up at the bottom of these units, right? But that's not going to happen. Right? There's not enough of them. So it would be nice if they lined up at the bottom of those, but they don't. Okay, so one thing you can do if you are the teacher is you can kind of think to yourself, which way am I headed with this? If you'll remember, I knew it was a negative 10x, so the negative was the bigger of the pairs of the x's that I put in there, but it wasn't the only one. I also had positives, right? And the problem is I'm missing a piece here. I don't have all the stuff that I need. So, what can I do about that becomes the issue. If I added some positive x's in there, and I can add positive x's either direction I wanted, but if I added some positive x's, maybe I could do something to make stuff line up in a particular way. It might help me out. So, what do you think? Positive x's. What could I do with that? You have to be a little bit careful because anything that I do with a positive x ends up being, I'm going to have to add in some negatives also, right? So in my brain I'm thinking, oh my gosh, maybe these don't need to be in this quadrant here. Maybe that's not working for me. Is there a way for me to rearrange them in a different way so that they're not all one long rectangle? Because, by the way, I'm going to have a problem here because I don't have enough of those unit guys, right? It's not going to make a big rectangle, right? I would need to fill in here, Okay, so I'm thinking maybe I can put some of them down here in the negative quadrant down here. They'll still be negative, but because I'm lining up with 3 instead of lining them up with just 1, it might change the way things look. And in my brain as the teacher, I'm thinking, I'm going to have to end up lining this stuff up. I've only got 10 negatives. I really need 12 negatives, right? How can I do that? If I needed 12 negatives and I only have 10 negatives, I could add on 2 more negatives, right? But if I do that, then what? Yeah, it's going to throw me off because I need some positives to go with them, right? Okay, so I don't quite see how that's going to line up here. What else can I do? What else can I do? What do y'all think? If I stuck them back over here, I mean, I could rearrange it a little bit like that. I know, again, as the teacher, I'm going to have to add some negatives and positives, do some zero pair things, basically, because I'm trying to make that be 12x. That would line up very nicely if I did something like that, right? But again, I'm thinking to myself, oh man, I've got to put in the 2 positives, so where could those go? Like, I can't put them there. Can I put them over here? Can I put them down here? What can I do with those? So this is my conundrum at this time. And what I would like to do is let you think about it. I want you to go back and think to yourself, what happened in here that, that I can see in my factors. So think about your AC method. I know I see what? 3x plus 2, right? And I know these negative guys right here need to be in the negative quadrant, okay? I know also that they won't fit in the opposite negative quadrant because why? Because they're not breaking in the right points, right? If they broke in the right points, then they'd have to be an x unit long. But they're not. I said a minute ago, they're only a unit by unit. They've got to line up basically at the end of these x squares. So what in the world can I do with it? These aren't in the right spot, basically, right? Yeah, I can move them up here, line them up with this x. Just remember that there's different dimensions for these Algeblocks, so I can move them up there. Does that help me any? Well, yeah, what did I just create? A gap for a 4 by 2, right? Okay. The gap for the 4 by 2, which is, oh, I apparently counted wrong. That's 8, right? Okay. Nobody said anything because I counted wrong. If you don't want it to go up vertically like that, like I said at the beginning, and you're looking at it like this, what's the problem? Well, the problem is that they're in the wrong one if I want to line them up properly, right? So I'd have to go to the negative quadrant down here. Line them up. It's okay. It'll work out. These guys all line up. And then I remember, hey, I put in some zero pair things, so these have to line up in the positive, but the only place they're going to line up is for their ends. They have to line up vertically or side to side with the x squares, right? But down here on the ends, they have to be a unit by unit, right? The ends have to line up with the unit blocks. Okay? So you could have done it down there also if you'd rather. Okay. No worries. Okay. This is where I'm looking at it and I'm going, okay, if I have to add the zero pairs in, it becomes a little tricky, right? Oops, sorry. it becomes a little bit tricky to add in the zero pairs. And the reason why is because I don't know exactly where they're going. They're things I'm introducing into the problem, so I really need to kind of think, okay, where would I put these? And how's that going to fit in? So I feel like I've got a good rectangle, either on the side here or up and down, whichever way you want to go. I just need to figure out what those factors are. And the problem with that is that I went off into the negative quadrant down here, right? So this factor is pretty straightforward. It's 3x, and then those two little pieces are going to be +1 + 1, or a +2. That's okay. But this one, remember we talked about this last week, you can have inside of the same factor some positive guys and some negative guys, right? So on this factor right here, I've got a positive x, but what the heck is going on down here? Yeah, those are -4, right? Okay, so you're going to have to line it up and see what's going on. It really sometimes bugs people when we put in that zero pair, like, okay, what's going on? And I knew, by the way, that 10 wasn't going to cut it. Because the only way for me to arrange 10, that's what I started out with originally, right? -10x. The only way for me to arrange them is either a 1/10 here, or a 2/4, right? But if I went for 2, that wouldn't be a rectangle, right? And if I went for just 2 here, that's only 2/3. Or I could have done like 3/3, but again, I don't have a rectangle. So I knew this isn't making me a rectangle. It's not going to happen. I'm going to have to go to zero pairs and fill in that gap, complete your rectangle, see how that goes. But because I added to this one, I have to add to the positive, and then I see, oh, those -8 fill in just fine. So pulling my factor track out, what is on the factor track? I've got a 3x + 2, and I've got an x - 4. So that negative guy's got to be in there. There it is. 3x + 2, x - 4. And it did. It worked out, right? We got it. Okay? So that's just a more in-depth look at what factoring looks like and how it's going to feel. Sometimes we don't know exactly how it factors, and we're like, okay, how am I going to make this work? And the answer is, well, sometimes you're going to have to use zero pairs. So just know that those are out there. Pay attention to them. Remember that last week we did some problems that didn't just throw me into 2 quadrants. They threw me into all 4. So you're either going to be in 1 quadrant, 2 quadrants, or all 4. You're never going to be in just 3 quadrants, right? Because if I was just in 3 quadrants, again, it wouldn't make me a rectangle. It's gotta all fill out. Okay, so that's it for that. We have one more topic this week, which is solving equations using Algeblocks. And honestly, I think that video should be relatively short. So, yay, let's wrap up Algeblocks. Coming back in just a minute with the second video.